Good morning, everyone. Today, what we are going to learn here, the indirect method for measuring the large distances. So, one of the method called triangulation method, we have already learned. Now, let's discuss today the another method called the parallax method. So, what is the definition of parallax method? Parallax is the apparent shift in the position of an object with respect to another object or with respect to a referent object. Now let's think about to learn about this parallax method. Everyone, please take your pen. Take one pen with you and keep this pen in front of your eye. Okay. Now you concentrate onto one point on the pen. So what you will do here, look at the pen top with one eye, with another eye closed. Say it as, I'm looking with my left eye, by right eye closed. And after that, look with the right eye by left eye closed. If this process you continue, okay, you can see that there is an apparent shift in the position of an object. Apparent shift in the position of the object with respect to some other background. With respect to background. And this is called the parallax method. So once again, what is the parallax method? Apparent shift in the position of the object with respect to a background. So look at the picture here. You are looking with left eye to an object. So object is given the O. Now, at the same time, you are looking with the right eye onto the same object. Clear? So definitely there will be apparent shift will be in the position. So here in this picture you can see the angle theta is marked. Angle theta. You are looking from two different positions, left eye and right eye. And this angle is called parallactic angle. Angle is called what? Parallactic angle. And you can see the distance between this left eye and right eye. And that is called basis. It is called basis. So I hope it is clear. So what is the parallax method? There is an apparent shift in the position of the object when you are looking from two different observing points. Here in this case, not a two observing point, this is two eye here. So there is an apparent shift is there, and this is called what? Parallax method. So you can see the equation here by using theta, plane angle formula. Theta is equal to arc length divided by radius. So we can calculate theta is equal to, what is arc length? Approximately we can take it as B, basis. And what is the distance here? It's marked as S. So theta is equal to B by S. So B also can be calculated. And here B is called what? The base. Now you are going to use the parallax method to calculate or to find the distance of moon or any planet from the Earth's surface. Okay. So you are going to use the indirect method called what? Parallax method. So look at the picture here. Just imagine we are going to find the distance of moon from the Earth's surface. So in order to calculate the distance from the moon to the Earth's surface, what should be done here? Once again, just imagine there is a two observing point on the Earth's surface. So in the picture you can see the A and B are the two observing point. Okay, or maybe observatory. Now what we are doing here, looking onto the moon, that is our object now, from the two different positions on the Earth's surface, that is A and B. So definitely while you are looking from A and B onto the moon, the position of moon there will be shift will be there, apparent shift will be there. In order to avoid that apparent shift, what we are doing here, we are taking a reference star. Say it as in the picture, there is a reference star is given as S dash. The distance from Earth to the S dash is almost or approximately equal from the two different observing points. that is A to S dash as well as B to S dash are equal, approximately equal. Now from the observing point A, you are looking onto the planet P using a, what is the instrument? We are looking to the faraway object, telescope. You can easily calculate the angle phi 1. The same way, you can go and look into the moon by using telescope, and you can also calculate the angle phi 2 because the reference star won't change, the position won't change, and the distance from A to B will be equal. So you can calculate the phi 2 here. If you know phi 1 and phi 2, you see in the picture you can see the angle APB can be calculated. Angle APB can be calculated. That is equal to what? Phi 1 plus phi 2. Phi 1 plus phi 2. So what is the parallax angle in this case? Or what is the parallactic angle in this case? The parallactic angle theta is equal to phi 1 plus phi 2. So what is the parallactic angle? Phi 1 plus phi 2, which is theta. So by using the plane angle formula, theta is equal to arc length divided by radius. Here what is arc length? So we are taking very distant object, right? So what is arc length here? Almost A to B, the distance between the two observing point on the earth surface. So A to B is known to us, right? Angle is also known to us. So you can see here theta is equal to B by S, or the distance from earth to the moon, S can be calculated, that is S is equal to B by theta. I hope it is clear. So this is the parallax method we are applying to measure the distance of moon or any planet from the earth surface. Now let's discuss, or once again you are going to apply the parallax method to measure the distance of a nearby star by parallax method. So for that, what we are doing here, we are taking two observing point. How you are taking two observing point? Just imagine the picture you can see here, A and B are the 2 points, that two position of earth actually. Earth is revolving around the sun. Look at the picture. And the sun is at the center. So at A, when the earth reached at A, and when the earth reached after 6 months, right, at B, almost equal, at B, from that two position, you are looking to the star, the nearby star. It is marked here in the picture, it is capital letter N. So as you already know, when you are looking from A and B onto the star, definitely there will be apparent shift in the position of the star. So in order to reduce that one, to avoid that one, what are you doing here? There must be a background image, or there must be a reference object. So here we are taking as a reference object. In the picture you can see the F is the reference object, maybe a very distant star, and that position and the distance from these two, A and B, will never change, or maybe approximately will be equal. We can say only approximation because it's an indirect method. We cannot say it's exactly correct. That means the same method, by using a telescope, you can observe from A when Earth is reached at A, and after 6 months you can look into the same star by using a telescope from B, and you can calculate the angle here in the picture, theta 1 and theta 2. If you find the theta 1 and theta 2, you can calculate the angle ANB can be calculated. What is angle ANB? That is called parallax angle, or it is called what? Parallactic angle. So what is the parallactic angle here? Theta 1 plus theta 2. As you all know, theta 1 plus theta 2. Once again, use the angle formula, plane angle formula. Arc divided by radius. Here, what is arc here? AB. What is AB here? AB is the distance between the two positions, A and B, are the two positions of Earth, maybe after 6 months gap. Okay, so that distance is known to us because the average radius of the sun and Earth is known to us, right? And so what is the distance from maybe A to N? That is, we can calculate here the D. Approximately A to N is taken as in the picture N to S. It's approximation because it's a very distant object, right? So N to S, or simply D, is equal to AB divided by theta. AB divided by theta. So this is another method for measuring a large distance or measuring a distant object by using parallax method. I hope it is understood. Thank you all of you.